Hey everyone, and welcome. Today we are going to dive into a pretty mind-bending new theory that tries to pull all of physics together, from the tiniest particle to the biggest galaxy. It's called shaking tangled dimensions. So, before we get into all the nitty-gritty, let's just start with a huge question. What if everything we see around us, all the matter, the energy, space, and time, what if it all emerges from the geometry of just one single fundamental building block? To really get why a new theory is even needed, we have to start with the biggest problem in modern physics. It's this deep, fundamental conflict that has, stumped scientists for the better part of a century. So on one side, you've got Einstein's general relativity. It describes the huge-scale universe, stars, galaxies, as this smooth, predictable canvas. It's beautiful. But on the other side, you have quantum mechanics, which is the rulebook for the bizarre, uncertain, and totally weird world of atoms and particles. The problem? Their descriptions of reality are completely incompatible. They just don't work together at all. This is where the tangled dimensions model comes in with a pretty radical solution. It suggests that maybe both of these powerhouse theories just emerge from something deeper, something more fundamental. A universe built not on a smooth canvas, but on a grid of something it calls cores. So what in the world is a core? Well, you can think of it as the ultimate pixel of our universe. As you can see here, each one is this intricate little unit. And according to this theory, literally everything in existence is made from a huge, interconnected lattice of them. Okay, so let's break that down. Each core is a single unit of space-time at the Planck scale. We're talking the absolute smallest slice of reality you can even imagine. And it's not just an empty point in space. It actually contains its own set of dimensions. The three spatial ones we all know, but also three separate electrical dimensions and three dark dimensions. These are the supposed fundamental ingredients of, well, everything. And this right here leads to a really profound idea. If reality is built from these discrete little cores, then space-time isn't continuous. It's pixelated, just like a digital photo on your screen. Now that one idea has massive implications, because a pixelated universe might naturally explain some of the absolute weirdness we see in the quantum world. Okay, so the universe is a grid of these cores. Fine. But where do actual particles, electrons, quarks, all that stuff, where do they come from? How does a static grid create the dynamic reality we actually see and experience? Well, the answer is surprisingly simple: a kink. See, according to this theory, a fundamental particle isn't a tiny ball of something. It's just a stable, geometric distortion, a little misalignment, in the electrical dimensions of a single core. The particle is the kink. It's not made of something, it is something. Let's see how this actually builds reality. So in empty, flat space, the three spatial dimensions inside each of these cores are separate, just kind of touching each other. There's no gravity, no acceleration. This is our baseline reality. But what happens when you introduce mass? Well, the dimensions get pulled together and they start to overlap. The theory proposes this is what gravity actually is. It's not some mysterious force, it's just the geometric consequence of these dimensions overlapping. And get this overlap also makes it harder for the whole system to update, which beautifully explains why time actually slows down in a gravitational field. Now this is where the elegance of the model really shines. Using just a few simple rules about how these kinks can be arranged, the theory claims it can build the entire zoo of fundamental particles we've ever discovered. This one chart, derived completely from the geometry of these kinks, describes everything from electrons to the most exotic quarks. Let's just look at a quick example to make it real. An electron? That's simply a core with one negative kink in each of its three electrical dimensions. An up quark? That's a core with one positive kink in two of its dimensions and nothing in the third. See? Different particles are just different geometric arrangements. That's it. So, the model is definitely elegant. But can it do what a real theory of everything is supposed to do? Can it actually solve some of the biggest, most persistent, unanswered questions in all of physics? All right, let's tackle some of the heavy hitters. For instance, why do fundamental particles come in three distinct families or generations? What is this invisible dark matter that seems to make up a quarter of our entire universe? And what exactly is that bizarre quantum property we call spin? The theory's answer for the three families of particles is surprisingly straightforward. It just comes down to geometry. There are exactly three ways that the three electrical dimensions can be cross-connected. None of them, two of them, or all three of them. That's it. 3 possibilities, 3 families. It just falls out of the model. And what about dark matter? Well, the theory points back to those dark dimensions that we said were inside each core. It suggests that dark matter isn't some exotic, new kind of particle, but the very same phenomenon, kinks, just happening in a parallel set of dimensions, interacting with our world only through gravity. The theory also offers a really fascinating explanation for spin. So in this model, spin isn't something a particle has, like it's a tiny spinning top. No, it's an emergent effect. A particle's electric field wants to be a perfect sphere, but it can't on a pixelated cubic grid. This tension causes the field to wobble, or precess, and that emergent wobble is what we measure as quantum spin. So if we take a step back and look at the whole picture, this theory isn't just about solving a few individual puzzles. It's really proposing a fundamental shift in how we view reality itself. And here's the ultimate implication. The universe is not a stage with separate actors called particles that interact using things called forces. Instead, everything, particles, forces, even space-time itself, it all just arises from the shape, the tangles, and the shakes of a single, unified geometric structure. The author of the theory, David Welker, makes his goal pretty clear with this quote. He's trying to replace the inherent weirdness and, as he calls it, mysticism of quantum mechanics, things like superposition, the observer effect, with a more intuitive, deterministic, geometric foundation. And this leads to the ultimate takeaway. The apparent randomness of the quantum world might just be an illusion. It could be emerging from the incredibly complex, yet totally predictable, oscillations of this underlying grid, a deterministic reality that's just hiding beneath a probabilistic surface. Now, of course, this is a very new theory. It needs a lot of scrutiny, a lot of testing, but it leaves us with a pretty fascinating final thought to ponder. Could everything we know, everything we experience, truly be the emergent result of simple geometry, of nothing more than shaking, tangled dimensions?